The third largest wildfire in California state history, the Thomas Fire, has burned for over 2 weeks and continues to burn. The fire has scorched nearly 250,000 acres of land, burned over 1,000 homes, and has forced tens of thousands of people to evacuate. Why has the fire been so destructive, and why does it continue to burn? Okay, let's science. On Sunday, the Thomas Fire not only became the largest wildfire this year for California, but also the third largest in state history. It sits just behind the Rush Fire that burned 271,000 acres in 2012 and the Cedar Fire that burned 273,000 acres in 2003. As of September 18th, the Thomas Fire is also the seventh most destructive fire, burning 1,024 structures. The fire began on December 4th, and nearly 2 weeks later it continues to burn. Over 8,000 personnel and close to 1,000 fire engines have been tasked to help contain and stop the fire from spreading. Their work is starting to pay off, with the fire at a 45% containment on Monday. Now, containment is a word you'll see often in reference to wildfires. It refers to the percentage of the fire's perimeter that has been controlled or stopped from spreading. For example, a fire that's 25% contained has 25% of its perimeter under control. It's the same for 50%, 75%, and you get the picture. When a fire reaches 100% containment, it doesn't necessarily mean that the fire isn't still burning, but that they have contained the burn to a set area and perimeter. Officials estimate that the Thomas Fire to be 100% contained on January 7th. So what event led up to this wildfire, and why did it spread so quickly? To answer those questions, let's get to the basics of how wildfires form. You need three ingredients. 1, you need fuel. 2, you need ignition. And 3, you need conditions to spread. You've probably noticed when you're starting a campfire, the drier the wood, the better it burns. The same goes for wildfires. The drier the fuel, the easier it is to burn. Fuel can be shrubs, bushes, trees, dead leaves, dead sticks, the list goes on and on. To understand how dry it's been in Southern California, let's look at some precipitation amounts thus far in 2017. November and December marked the beginning of the rainy season in Southern California, racking up 1 to 3 inches on average every month. But thus far, November and December have been bone dry. June, July, and August are normally the driest months for the area, and this year was no different, with little to no precipitation falling from Santa Barbara to LA. The area has seen essentially no rain since June, giving fuel ample time to dry out. Fires are also more susceptible in areas that haven't burned in a while. Litter just piles up on the forest floor and sits there waiting to be burned. One tactic used by the Forest Service designed to prevent this from happening are controlled burns of the litter. Next up, ignition. Stuff just doesn't spontaneously combust. It needs something to trigger the flame. According to the National Park Service, 90% of wildfires are caused by us, humans. It can be a power line falling over due to wind, someone throwing a cigarette out the window, or a camper leaving a fire unattended. Whatever the trigger may be, these actions cause 90% of wildfires to form. I'll take a line from my buddy Smokey the Bear: only you can prevent forest fires. Whatever you're doing, just please be aware and please be cautious. Now, the other 10% are caused by natural things like lightning or lava. The cause of the Thomas Fire is still under investigation. The final ingredient to a large wildfire is weather conducive to rapid spreading. A big part of this are strong winds. In the case of the Thomas Fire, a high-pressure system was well established across the Pacific Northwest and into the northern Rocky Mountains. Air rotated around this high-pressure system in a clockwise fashion, giving Southern California a northeasterly wind, commonly known as the Santa Ana winds. The direction of this wind is important. A northeasterly wind is perpendicular to the mountains, which means they have to go up and over before descending back down. This warms and dries the air out before reaching the greater Los Angeles area. As the air descends, it compresses, which causes the air molecules to move faster and the overall temperature to increase. Assuming little to no moisture is added or removed, an increasing temperature causes the relative humidity of the air to plummet. These winds ramped up to 70 miles per hour and set the stage for a disaster the night the Thomas Fire began. This general pattern has persisted, extending a nightmare for Southern California residents. I've included several links in the description below if you want to donate and help out in the relief effort, one of which is the Thomas Fire Fund. that you can find at vcunitedway.org. So, those are the basics of the Thomas wildfire and why it has continued to go and spread over the last 2 weeks. Officials expect 100% containment on January 7th. That's just an estimate. Could be later, could be earlier. But when that does happen, things can start to return to normal for this area. Thanks for listening.